Neuraminidase or sialidases are enzymes that cleave the glycolytic linkages of neuraminic acids or sialic acids. The first step of the enzyme reaction is the removal of glycoconjugate. The electron goes here and comes here. This reaction forms an oxygen anion, shown here. Then this intermediate is called sialosyl cation. The next step is addition of water to form the alpha anomer. The alpha anomer is converted to more thermodynamically stable beta anomer. If you do not understand the concept of anomer, please watch a different video. This is the crystal structure of influenza virus N2 sialidase bound to the alpha N-acetyl-neuraminic acid. So you can see the substrate right here. Here's the substrate. Let me expand the binding site. So now you can see a 6-membered ring structure right here and carboxylic acid right here. Let me expand a little bit. You see 6-member ring here and the acid right here. By the way, the red indicate an oxygen atom and blue indicate a nitrogen atom. How can you make an inhibitor of this enzyme? Let me go back to the mechanism of the enzyme reaction. As I mentioned earlier, sialosyl cation is a transition state intermediate. The one way to design the enzyme inhibitor is to mimic the structure of such a transition state. What you are looking at here is the structure of natural substrate. As I mentioned earlier, the transition state has an oxygen anion, cation. This is the structure of transition state analog. These two are similar to each other. This structure served as a starting point for the design of potent inhibitors. By looking at the structure of the enzyme, Professor von Edelstein thought that putting a basic functional group right here, might potentiate the activity. The first thing he did was to put amino group right here. This amino molecule had about 100 times more potent than the original molecule. More importantly, this molecule had little activity against human neuraminidases with greater selectivity to influenza neuraminidase. The Professor von Edelstein designed a guanidino version of this molecule and found that this molecule was even better. This is how Lidenza was discovered. Lidenza is most effective when given during the early stage of infection within 48 hours from the onset of flu symptoms. However, Lidenza is not orally available. It cannot be taken orally, inhalation only. that this product comes with inhalation device. Then there was a demand for an orally available influenza drugs. Inspired by Lidenza, Tamiflu was developed. Tamiflu has a lot simpler structure. Carboxylic acid, right here, was esterified for better oral availability, and the ring structure and also the alcohol moiety were simplified, these two. The Tamiflu comes in a pill form and can be taken orally. Since oral administration is much easier, this drug became more popular than the Lidenza. In the next video clip, I will show you an example of fast follower approach in the field of music.